Welcome to our session on understanding artificial intelligence models and their underlying capabilities. Today, we are going to unpack the building blocks of automated intelligence, explore how different systems function, and examine what they are truly capable of doing. Understanding these concepts is not just about passing an exam. This knowledge is directly applicable to your daily professional life as an auditor or technology leader. When your company proposes buying a new automated tool, you will know exactly how to classify its intelligence level. You will be able to pinpoint whether a system poses a severe data privacy risk or if it is simply a basic rule engine. This allows you to ask the right questions during vendor assessments and design appropriate control frameworks for your enterprise. Let us begin by untangling three terms that people often mix up. Those terms are artificial intelligence, machine learning, and deep learning. They actually sit inside one another like nesting dolls. Artificial intelligence is the broadest category. It refers to any computer system that can mimic human thinking or perform analysis based on a set of rules. Think of artificial intelligence as the entire concept of motorized transportation. It includes everything from a basic motorized scooter to a massive high-speed train. Moving one layer deeper, we find machine learning. Machine learning is a specific subcategory of artificial intelligence. The secret ingredient here is data. Instead of programming a computer with strict rules, we feed it historical data so it can build a predictive model. It uses statistical math to find patterns in that data, which it uses to make predictions about new data. Imagine you want to sort apples from oranges. Instead of writing rules about colors and shapes, you show the machine thousands of pictures of apples and oranges until it figures out the difference on its own. At the very center is deep learning. This is a highly advanced type of machine learning. Deep learning relies on multi-level algorithms that process information in layers, getting more abstract with each step. For instance, when looking at a photograph, the first layer might just see edges. The next layer sees shapes. The final layer recognizes a specific human face. Because of deep learning, we now have incredible breakthroughs in translating languages and understanding spoken words. Now, let us look at how we categorize these systems based on their functionality. There are four functional types to remember. The first type is the reactive machine. This is the oldest and most basic form. It reacts to a very specific set of inputs and generates an automatic response. It has no memory of the past. Think of a classic arcade pinball machine. The flippers only move when you press the button. It does not remember your last game or learn your playing style. It just reacts. The second type is limited memory. This is where most modern technology sits. These systems hold a static baseline of knowledge, but they also have dynamic memory to briefly store recent observational data to complete a task. Imagine a smart thermostat in a modern office building. It knows the static layout of the building, but it dynamically reads the temperature over the last few hours to decide when to turn on the air conditioning. It uses those recent brief memories to make a better decision today. The third type is theory of mind. We are still in the early stages of this. Theory of mind means the machine understands that humans have thoughts, ideas, and emotions that drive our behavior. The machine can process social interactions and adapt its responses based on the emotional state of the user. Imagine walking up to an airport kiosk. If the kiosk had a true theory of mind, it would realize you look stressed and are speaking frantically. It would automatically adjust its tone to be calming and bypass the standard menus to get you immediate help. The fourth type is self-aware artificial intelligence. This does not exist yet. This requires a machine to not only understand human emotions, but to possess its own consciousness and desires. Building this requires a mastery of neural networks and deep learning that we simply have not achieved. Beyond functionality, we must also audit systems based on their overall capability. There are three levels of capability. The first is artificial narrow intelligence. This is often called weak intelligence. It only operates within a highly specific domain. It is incredibly fast and accurate, but it completely lacks genuine consciousness or broad understanding. Think of an automated warehouse robot. It uses cameras to scan barcodes, a positioning system to navigate the warehouse floor, and an internet connection to sync inventory data with a central server. It navigates around drop boxes and wet floors perfectly. However, if you ask that same brilliant robot to write a poem, it will fail completely. It is confined strictly to the domain of moving boxes. Narrow intelligence covers all reactive and limited memory systems we discussed earlier. The next level is artificial general intelligence. This represents a machine that can perform any intellectual task a human can do. To reach this level, the system must master 7 specific traits. It needs sensory perception. It needs fine motor skills. It must handle complex problem solving. It needs navigation abilities. It requires a deep understanding of natural language. It must possess creativity. Finally, it needs social and emotional engagement. We are making strides in language and vision, but mastering things like fine motor skills and common sense keeps this level out of our current grasp. The highest capability is artificial superintelligence. This is purely theoretical. This level transcends human capability entirely. It would solve impossible scientific problems at unbelievable speeds and possess its own consciousness. This is the type of intelligence that could radically alter human history with groundbreaking novel solutions. Let us transition to specific technological models you will encounter in the field, starting with generative models. Generative systems create entirely new, original content. This includes writing code, painting pictures, composing music, or synthesizing human voices. They do this by studying massive amounts of training data and identifying the underlying patterns. The most revolutionary architecture behind this is the General Adversarial Network. We call these networks GANs. The concept is brilliant. It relies on 2 competing neural networks working against each other. One is the generator. Its job is to create fake data. The other is the discriminator. Its job is to catch the fakes. Imagine a chef trying to recreate a famous secret recipe and a food critic tasting the attempts. The chef keeps adjusting the ingredients, and the critic keeps saying whether it tastes authentic. Eventually, the chef gets so good that the critic can no longer tell the difference between the replica and the original. This dual network approach is what allows us to create highly realistic synthetic video and audio. However, as an auditor, you must look out for the severe risks tied to generative platforms. There are massive ethical and legal concerns. Generating and distributing harmful or biased material can result in severe legal penalties. Furthermore, because the machine learns from existing human data, there are major concerns regarding copyright infringement and intellectual property ownership. Next, we must cover agentic artificial intelligence. This is the next frontier of digital assistance. Unlike standard automation that just follows a script, agentic systems can actually make autonomous decisions to reach a specific objective. There are 3 main benefits to deploying these agents. First, they offer greater workplace specialization because they are built rapidly to handle very granular, specific workflows. Second, they are highly capable of innovation and experimentation because of their strong problem-solving judgment. Third, they provide increased trustworthiness. They are far less likely to make up false information, which we call hallucinations, compared to standard generative tools. This makes them reliable for making decisions that align with corporate values. Of course, they still need human oversight. If a human gives the agent a poorly articulated goal, the agent will struggle to succeed. You will see these agents used extensively across 6 key areas. These include customer service, healthcare diagnostics, manufacturing operations, managing complex workflows, calculating financial risk, and supporting sales teams. The final concept is predictive models. Predictive systems look backward to see forward. They use historical data and machine learning algorithms to forecast future trends. Think of it like a seasoned farmer analyzing decades of soil and weather patterns to predict exactly when to plant next year's crops. In business, you will see these used for 3 main applications. They predict when manufacturing equipment will break down, they forecast financial market shifts, and they predict when a retail customer might cancel their subscription. The audit risk here lies in the business decisions made using these forecasts. Both the developers and the business users must deeply understand how the machine arrived at its prediction. If leadership blindly trusts the output without verifying the factual basis of the model, they risk making catastrophic business errors. Let us recap what we have covered today. We explored the hierarchy from broad artificial intelligence down to deep learning algorithms. We defined the 4 functional types, from simple reactive machines to future self-aware systems. We examined the 3 capability levels, noting that we currently operate in the realm of narrow intelligence. Finally, we broke down the mechanisms and the unique risks of generative tools, autonomous agentic systems, and predictive models. To master these concepts, you need to practice them. All the important topics and concepts from this session are covered in the multiple choice questions on rucloud.com. I highly recommend you solve the chapter-specific questions to reinforce your learning before moving on to our next session. Thank you for joining me, and I look forward to continuing our journey next time.